Example 4. Again, we want to check if this integral is diverges or converges. Okay, this integral, I'm going to use integration by part, alright, which is integral of u dv is equal to u times v minus integral of v du. I'm going to let my u be 1 minus x, alright, so my du will be negative 1 dx. So my dv will be the rest, which is e to the negative x dx. Take an integral of this, I will have v e to the negative x, and derivative of negative x is negative 1. Alright, so we're going to plug it in. So I'm going to have u times v minus an integral from 1 to infinity v. Alright, this is my v du. This whole thing is du. Alright, the first part I don't have to do anything. The second part I have to take an integral of e to the negative x dx from 1 to infinity. Again, in this case, my u is negative x, so I need negative 1 here and negative 1 here, right, to fit the formula. So I would end up with positive e to the negative x and plus c, which is constant. Now I'm gonna simplify these two terms. One is minus, one is plus. I can simplify them. I left with x e to the negative x plus c. Alright, so far so good. Alright, next I'm gonna apply the definition of an improper integral. So what I did here, I take a limit as b go to infinity of the function from 1 to b. Alright, now I substitute the b in, so I have b over e to the b minus 1 over e. Right? Next step I did is I break into two parts. The first part is b over e to the b. Now, as you check and use L'Hopital rule, you will see this. As b go to infinity, you have infinity over infinity for the first term. Alright? Now I'm going to use the L'Hopital's rule. So for the first one, derivative of b is 1. Derivative of e to the b is e to the b. The second term is remain the same. Alright? As b go to infinity, I have 0 for the first term. Alright? The second term, limit as b go to infinity, 1 over e is negative is this negative 1. This negative is this negative 1 over e, which is converges. Alright, let's see next example. Hi everyone, let's look at the next example. Example 5. I have an integral from 0 to 2 from this function. You might notice that when x equal to 1, we have 0 on the denominator. So we cannot have x equal to 1. Alright, so what I'm going to do, I'm going to break it into two integrals from 0 to 1 and 1 to 2. But I will not let it equal to 1. I'm sorry, I will not let it equal to 1. It's going to approaching 1 from the left, alright, and approaching 1 from the right. So I have this two integral. Alright, I'm going to take an integral of the first one, as you can see in the note here. Alright, I rewrite it as exponential, which means you're going to have x minus 1 quantity raised to negative 1/3, and then you take an integral of this, which means you plus 1 to the exponential, you got 2/3, and divide by 2/3. Alright, so I reciprocal it, I get this, take a limit as b approaching 1 from the left. So it cannot be 1, close to 1 from the left, from 0 to b, and then limit as c approaching 1 from the right. It's not equal to 1, but close to 1 from the right of the function that I just showed you here. Alright, let's plug in the upper bound and lower bound. You get this whole thing. Alright, as b go to close to 1 from the left, this whole thing is approximately 0. So you're going to have 0 for the first term. Minus 3/2, and this is negative 1 to the 2/3. Alright, so for the first term, you're going to have negative 3/2 because this is going to turn to 1. Alright, for the second term here, 2 minus 1 is 1. 1 times 3/2 is 3/2. Alright, c minus 2, as c approaching 1 from the right, this one going to approach almost 0, about 0. So you're going to have positive 3/2. So negative 3/2 plus 3/2 is 0, which is converges. So I'll see you in the next example. Hi, let's look at the next example. Alright, I have an integral from 0 to 5, 1 over 25 minus x squared dx. This one I'm going to use partial fraction decomposition. I factor out the denominator, right, because it's distinct linear. So I'm going to have a over 5 plus x plus b over 5 minus x. Alright, next I'm going to get rid of denominator. So I multiply both sides by 5 plus x times 5 minus x. I would have 1 on the left hand side, a times 5 minus x plus b times 5 plus x on the right hand side. Now the next step, we all can do different things, but this is what I'm doing. I'm going to get rid of one variable at a time. So if I let x equal to 5, I will get rid of a. Alright, then I will have 10b is equal to 1. b will be 1/10. The next one, I will let x equal to negative 5. Then I will get rid of b. I will have 1 equal to 10x. Alright, I will get 1 equal to 10a. Then a will be 1 over 10. Alright, now I'm going to substitute this for a and b. Alright, so the integral of 0 to 5, 1 over 25 minus x squared dx. Again, I have to let b approaching 5, not equal to 5 from the left. Alright, that's the integral from 0 to 5, but it cannot be 5, so it goes from the left. Alright, I factor out the 1/10, and then I left with 1 over x plus 5 minus 1 over x minus 5 dx. Alright, the next step I did is I factor out the 1/10. Alright, and you have two parts here. Alright, I have to take an integral of this and this. Alright, I'm using this formula right here for both of them. So by doing that, I have limit as b go to 5 from the left, 1/10, ln x plus 5 minus ln x minus 5. The lower limit is 0, the upper limit is b. Alright, then I will rewrite it a little bit, use log definition. I put them in quotient. Alright, now let's take a look at this. I direct substitute upper bound with b, alright, and lower bound with 0, which I will have this. If you try to substitute any number that very close to b 5, very close to 5 from the left, in here, very numbers really close to 5, then you're gonna end up with infinity. So ln infinity is infinity. So 1/10 times infinity is infinity. The other part, I will end up with absolute value of 1, which is ln 1, and ln 1 is 0. So the second term is becomes 0. Alright, so infinity minus 0 is infinity. So it's diverges. So let's look at the next one. Hi everyone, let's look at the last example of 8.8. Alright, look at this interval from 4 to infinity, square root of x squared minus 16 over x squared dx. Again, I take limit as b go to infinity. Alright, integral from 4 to b and the function itself. Now if you remember, we have a formula in appendix b. This is formula 30, and the formula says an integral of square root of u squared plus or minus a squared over u squared equal to all of this. So look at our integral. It's fit perfectly. So my u is my x, my a is the 16. Alright, so I'm going to apply the formula here into my problem. So I'm going to have limit as b go to infinity minus square root of x squared minus 16 over x plus ln absolute value of x plus square root of x squared minus 16 from 4 to b. Alright, next step I did was I substitute the upper bound, which is b. This whole thing is upper bound. Alright, and lower bound is 4. Alright, let's start from the easy one. Ln 4 is just 1.386, so that's Ln 4. Alright, look at the middle term here. As b go to infinity, this whole thing will go to infinity. So you have Ln infinity, which is infinity. Alright, so the little bit tricky one is the first term here. We really don't know what it is, right? Just look at it. So what I'm going to do, I'm going to divide every term by b. The one in radical, because b is equal to square root of b squared. Alright, so inside radical you have to divide by b squared. So I did that. Alright, now the b squared and b squared cancel out. I get 1. Alright, and then I have 16 over b squared, and the bottom is just 1. Now as b go to infinity, this term here will go to 0. Then I'm gonna have negative square root of 1 over 1, which is 1, which is negative 1, plus infinity minus 1.386, which is infinity, which is divergence. Alright, I finished 8.8. I hope that we go back to the normal soon. That way we can take the test in class. However, if the school decide that we're going to continue online, I will email you the instruction about how to take online tests. Alright, in the meantime, please make sure you practice as much as you can. Do your homework. Alright, and I'll email you later. Thanks. Bye.